Hello, welcome to another module in this massive open online course. So, we are looking at an application of convex optimization in big data, in particular to the Netflix problem. So, let us continue our discussion. So, we are looking at big data, in particular the Netflix problem. Let us consider a very simple version of that problem, and to do that I will consider a very simple example, a very simple. Of course, the Netflix problem, as I said, involves about 500,000 users and about 20,000 movies. We are going to consider an extremely simple version of that, which can be generalized, of course, to any size, since it basically illustrates the key principle. So, what I have here is a very simple example. Remember, Netflix problem, there are users who are rating the movies. So, this is a simplified version of the problem. Let us say that you have 3 movies A, B, C. These are your movies, and 3 users 1, 2, 3, similar to the table that we had seen yesterday. These are the users, or these are the viewers. I am just going to call them as the users of Netflix, or you can also think as these are the viewers, or you can also think of these as the subscribers to Netflix. And let us say different users have rated different movies. Let us consider again a simple example where user 1 has rated movies A, B, C. The ratings are 3, 5, 3. User 3 has also rated movies A, B, C. Ratings are 2, 5, 4. But user 2 has only rated movies A and C, and his ratings are 4 and 3. Now, what you can clearly see is that one rating is missing. If you look at this as a matrix, this is missing. This is missing. Okay, and therefore, we have to predict this rating to complete this matrix of users and ratings. That is why it is also known as a matrix completion problem. That is what we had seen previously. Okay, so this problem where you are trying to complete this matrix of users and their ratings for the movies, this is also known as a matrix completion problem. Okay. So this is a matrix. This is a matrix completion problem. And how do we address this matrix completion problem? Well, there are 3 movies A, B, C, 3 movies. Three users, okay. How many ratings are there? Total 8 ratings, maximum is 9. Total 8 ratings are available. 1 is missing. What is that? Rating of user 2 for movie B. This is missing, which we have to predict. Now, again, let us consider a simple predictor. What is a simple predictor? A very simple predictor. You can also think of this as a back of the envelope calculation. What is a simple predictor? If you are just looking at a very gross average, if you are just looking at reducing this entire process to a single number, what is the best predictor? The best predictor is nothing but the mean, that is the average. like the per capita income of a country. If you look at the total gross domestic product divided by the number of people, that's a simple metric that shows what is the average rating of each movie per user. Okay, so we compute the average. That is the simplest and the simplest predictor. Might not be the best, but is the simplest. Okay, so the simple predictor is simply take average across, this is a gross oversimplification, okay, but as I said, it's simple. Take an average across all users and movies. So we have a rating A, which is 1 over, let us say S is the set of all ratings that are available, U comma M, that is user U has rated movie M belongs to S, R rating R of user M. Okay. So what is this R of U of M? R U M equals rating of user U for movie M. Example, R of 1 comma C equals 3, rating of user 1 for movie C. Okay, so very simple notation. All right. Now S is the set of all ratings available, or the S is the all the pairs U comma M, or S contains all the pairs U comma M such that user U has rated movie M. Very simple. I mean, I can only consider the average of all ratings that are available. I mean, if user U has not rated movie M, I cannot include it in the average process. So all the ratings that are available, simply take the average of that. Okay, and this quantity, if you look at it, this is standard. This is basically the number of elements. So I'm dividing with it equals number of elements, total number of ratings equals number of elements in S. Okay. So now this is also termed as a lazy predictor. Okay, you can think of this RA, this is R average, this is, you can think of this as average rating. Okay, so you can think of RA as a lazy predictor, something that, as I said, is a back of the envelope calculation. That is something that you would do if you just grossly oversimplifying the entire process. And for this example, the average is RA equals 1 over 8, total number of ratings is 8. Simply take the average, 3 plus 5 plus 3 plus 4 plus 3 plus 2 plus 5 plus 4. This you can check is 29 divided by 8 is 5 plus 8 plus 11, and for 15, 18, 20, 25, 29. 29 divided by 8, 3.625. So average rating of each user for each movie RA equals 3.625. But as I have already told you, this is simple, very simple. Its performance is going to be very poor, but caution, this is a very poor predictor, because this is a gross oversimplification. This is a gross oversimplification. Why is that? The reason for that is, I mean, we are not robots, right? Each user is each user is unique, each movie is unique. Okay, so each user has a certain bias. Each movie is good. Remember, when we look at a movie, I mean, everyone might not agree on the movie, the quality of the movie, but by and large, some people, a large number of people think some movies are better than some other movies. For instance, if you look at the movie Godfather, a large number of people would think that Godfather is probably the best movie that is ever made, right? And so on and so forth. So some movies are consistently rated the best, Some movies are some movies are, of course not everyone is agreeing, and don't mistake me, not everyone is agreeing on every movie, but some movies are better than others. Some users are same way more lenient towards their ratings, while some users, for instance like critics who write in newspapers, might be very harsh usually. Okay. Now, so one has to take the vagaries of this process into account. So to each user, each movie is either good or bad. I mean, there is inherently a certain quality which makes a movie good or bad. Similarly, each user has a certain bias. Some of us like certain kinds of movies, some of us like comedies, some like romantic movies, and so on and so forth. So bringing the human aspect into it, both into the movie making as well as the movie rating aspect of it, all movies are not identical. Not identical. Okay. Similarly, not all users are all user preferences or prejudices are not identical. Implies each movie is good or bad or each movie has a certain bias, each movie is good or bad. Okay. And each user has a certain bias, each user has some bias. So we can model the rating of each user RU of M. A slightly more sophisticated model is the average plus the bias of each user plus the bias of movie, which captures the good or bad nature of the movie, and BU captures. So this BU is the bias of user U, and BM is the bias that is shows if a large number of people think that the movie is good or bad. So this is a simple, slightly more refined model. Simple but slightly more refined model. This is a natural model because some movies are better or worse, or some movies are worse, and some users and different users have different biases. So this is a slightly more refined and probably a more natural model in capturing the behavior. And therefore now if you look at, for instance, again let's go back to look at R1A, that is the rating of user 1 for movie A. This can be split as the average plus the bias of user 1 plus the bias of towards movie A. Now we know what is RA. We know that RA equals 3.625, and we know R of 1A, that is the rating of user 1 for movie A. If you go back, look at our table, that should be equal to 3. Let me just check. Yes, that is indeed equal to 3, and therefore 3 equals 3.625 plus bias of user 1 plus bias towards movie A, bias of movie A. So which implies 3 minus 3.625, this is equal to B1 plus BA, which implies, well, minus 0.625 equals B1 plus BA. Okay, this is an interesting result that you have. Similarly, if you look at this, Now let us consider rating of user 1 for movie C, that is equal to, well, what is that? You go back and look at it, that is equal to 5. I am sorry, rating of user 1 for C, that is equal to again 3. Let us consider rating 1 of 1B, rating of user 1 for movie B, that you can see is 5. So rating 1 for user B, which is 5, which is again RA plus B1 bias of user 1 plus bias of movie B, which implies 5 minus RA, 5 minus 3.625 equals B1 plus BB implies 1.375 equals B1 plus BB. You can form all such equations. In fact, you will have 8 such equations. Since you have 8 ratings, you will have 8 such equations. So let us write down the equations. You have minus 0.625. Let me just write the 8 equations clearly. 2 we have already seen, minus 0.625 is B1 plus BB, 1.375 equals B1, I am sorry, this is B1 plus BA, this is B1, 1.375 is B1 plus BB, 0.375 or minus 0.625. I am just going to write these things equals B1 plus BC, 0.375 equals B2 plus BA, minus 0.625 equals minus 0.625 equals B2 plus BC, I am sorry, this should be B2 plus BC, minus 1.625 equals B3 plus BA, 1.375 equals B3 plus BB, and 0.375 equals B3 plus BC. Okay, this is the set of equations. You can see this is a system of linear equations. What is this? This is a system of linear equations. I can write this in the form of a matrix. So you write this in the matrix form. So you will have vector on the right, minus 0.625, 1.375, you can check this, minus 0.625, 0.375, minus 0.625, minus 1.625, 1.375 and 0.375. Perfect. This is equal to the matrix 1 0 0 1 0 0 1 0 0 0 1 0, that is user 1 movie B, 1 0 0 0 0 1 0 1 0 1 0 0 0 1 0 0 0 1. You can see user 2 for movie B is missing, rest you have user 3, movie A, user 3, movie B, user 3, movie C. That's it. That is the matrix, and then you have the vector of, let's write it down, B1, B2, B3, bias of movie A, bias of movie B, bias of movie C. Okay, and now you have this vector R bar, this is A, this is B bar. So you have the system of equations R equals A times B bar. This is 8 cross 1, this is 8 cross 6, and you can see how many equations, number of equations equals 8. How many unknowns? Number of unknowns equal to 6, implies more equations than unknowns. All right, we know, we have seen this several times, this is an overdetermined system. This is an overdetermined system. And how do I solve this overdetermined system? We solve this overdetermined system by using least squares, R minus A B bar square. We cannot solve this exactly, we have to solve it approximately. How do we solve it? We find the best vector B bar, which minimizes the approximation error, norm of the approximation error R bar minus A B bar. So you minimize R bar minus A B bar, this is your least squares problem. Implies B bar equals A transpose or A, I am sorry, B bar equals A transpose A inverse A transpose B bar, that's it. So from this you get B bar, this will give you B1, B2, B3, BA, BB, BC. The predictor of rating of user 2 for movie B will then be the average plus B2 plus BB. This is a slightly more refined, better predictor. This is slightly better, but not the best. We are not done yet, but slightly better, but not the best, okay, we are not done yet. Alright, so we have got first stage, we started with the average, we have refined it, average plus bias of user, bias of movie, that gives us something. Alright, but we are not done yet, we are going to refine this model further to predict it, to get as close as, remember, we have to be able to predict it as closely as possible, and towards that end we are going to refine this model further, and that we are going to do in a subsequent model. Thank you very much.